Right. So welcome everybody to the show and tell meeting of the first EESSI hackathon. So we want to check how things went, who worked on what got finished, what is still open, and also some general feedback on the whole experience. So yeah, agenda will just work our way through this. There's quite a lot of slides, but hopefully we can keep the meeting relatively short. Let's maybe start with some general feedback on how things went. I know some people included that in their slides as well, but maybe it's good to already say something about that. So how do people feel? How did it go? Was the setup working with the HackMD notes and Slack and the 3 Zoom calls we had? Any comments?
I'd like to thank the organizers. It worked really well to actually set aside some time and get crap done. Maybe the word crap wasn't the best opening for a meeting, but yes.
Having the event actually helped with setting some time aside to work on stuff. Yeah.
And also maybe a comment from me as a newcomer. So I never really looked into the details of EasyBuild and Easy myself, but I really could get started with this and do some meaningful work, I think. So for me, it was good.
Right.
And I liked how it was spread across whole week. So we could work on tasks at our leisure. And it's not like smashed together into one day. That's good.
Mm-hmm. Yeah, I think that was very helpful as well. So I think lots of us have also real work to do. And then at least we could get some stuff done for the hackathon in between other things.
Maybe one negative from my side. So I think it was a little bit hard so some of the tasks are a bit complex for newcomers and not being coordinated and people having different schedules kind of messed up with that a little bit. I'd say in the GPU task, I think it was probably hard for people to get started. Also because they were relying on me to have something in place first, which wasn't, right? Which took 2 days to do. So.
Mm-hmm. So how could we change things? Like more fine-grained tasks, more specific things? Or
maybe more specific things, but I also think that the fact that we have something that kind of works in place and the next step would be tweaking that would make that much better, right? So starting from scratch, but not coordinating a schedule between multiple people is probably not the best way to go. But
I guess that's something that's reasonably difficult in this virtual format, and you wouldn't have this if you're doing this in a day or maybe 2 days at a physical event. But yeah, that's probably something we can do better. Okay.
For me, it was my first hackathon. I really enjoyed it. Okay, one of my advantages, I dare to say I'm fairly familiar with EasyBuild and also Easy a little bit. And some of the bits I was using I already had basically done and ready to be just adjusted, in particular my container. If I really had to start from scratch, probably my time would have been a little bit too tight here. Mm-hmm. But by and large, I think for me, it went quite well. Like most people, I had a daytime job. Well, I still have a daytime job. And I managed to work around that. I guess one of my advantages is I was working in the evening. And as Bob was the only other member of the team, somehow that worked out. I do understand if it was a larger team, then that is a little bit more tricky to organize.
Yeah. I saw somebody else mention that as well. I think was it Caspar? About the small teams, that was very helpful.
Yep. Yeah, I think it worked well. Like it's hard to coordinate with 10 different people with yep. You know, somewhere between 2 and 4 people. I think it's pretty easy.
Mm-hmm. Yeah, makes sense. Any other comments, or shall we move on? So I think maybe the main thing to change would be to fine-grain tasks, or maybe easier tasks with a bit more guidance on how to start on stuff. That would be helpful. Okay. But overall, yeah, I think it works quite well. Then I also took a quick look at the credits we spent in AWS for this. So one of the reasons to organize the hackathon was because we still have a big bag of sponsored credits from AWS who are gonna expire end of January. So we weren't shy to try things like GPU nodes or nodes with high performance network. And we did a lot of that as well. But altogether, I would say the credits that we spent specifically for the hackathon, so next to the basic things we have running, so we have a Stratum 1 running in AWS as well. So that's mostly these low costs here. That's from Saturday and Sunday before the hackathon. Everything upwards from there is basically specific to the hackathon. So if you take everything together, today is not complete yet, but we've spent about $700, so it's going to be like maybe $900 in total. So that's not a lot, and certainly well within range of what we had in mind. Even 5 times this would have been fine, fine as well. So yeah, I think we're doing good there, and there's a lot of room to spend more if we want to do more aggressive or more large-scale testing. Maybe for this hackathon, it's not strange that we didn't use a lot of resources yet because we were getting started with a lot of things. But once, maybe in a future hackathon, once more things are in place and we can make more progress to bigger things, this will change a lot. We'll see how that goes. Okay, then I think we can start looking at the tasks individually, see what was done there, starting with the one that I was the lead for, even though I didn't do a lot of stuff myself this week, certainly a lot less than I was hoping. So we had 3 main things that we worked on. So we started looking at user-facing documentation. So what do people who want to use Easy and who want to build software on top of what we provide in Easy, what do they need to know? What kind of caveats are there? So things like the mount you get is read-only. You cannot just install additional software in there. It has to go somewhere else. You have to be careful with not picking up libraries from the host. So you need to make sure you only use stuff from the compatibility layer. You probably need to use RPath and so on. So this is just a starting point. It's certainly not complete, but we'll keep massaging that and make it a proper pull request to the documentation, probably a separate page on things you should know, things you need to take into account. And hopefully gradually we can put things in place to make that as easy as possible, based on some of the stuff that was done in this task. Something that Hugo played with, which he already mentioned Wednesday as well, is testing the build of Wharf on top of our previous pilot. So this is using Easy Build that makes it relatively easy. So as long as you're running the build in the prefix environment and you're using a properly configured Easy Build, then it basically works without much trouble. So as long as Easy Build is installing outside of the CVMFS mount, then it's actually doing fine. So the main takeaway here is that we need we need to provide a very easy way to configure Easy Build properly. Probably as a separate init script that we include in Easy itself, so people can just source that and get started.
Should we offer from Easy to have a easy build kind of thing, like so that when you install Easy, you get a properly configured Easy build that just needs a place to dump stuff, and that's that basically? Yeah, so that's indeed something we could do, either maybe sourcing a script or just loading an extra module. Well, like easy build configuration or something like that. That maybe even gives you some guidance, maybe a link to documentation. If you want to do this, please take this into account, something like that. So we can definitely make this a lot easier than it is now. But as long as you're using Easy Build, this is not rocket science. So if you know Easy Build a little bit and you know a little bit of how Easy works, then it's actually quite doable. But we can make it a lot easier. The Easy Build configuration should be very easy, and a wrapper script that runs the commands in the prefix environment for you, so you don't have to do that manually. So making that transparent is certainly possible and something we should do. And then the biggest chunk of work done in this task was done by Martin. So I'll let Martin explain that himself.
Okay, so this project was motivated by, if you as a user check out or load the GCC module, for example, and you want to build your own stuff with this compiler, then you have to consider where the libraries are picked up from. And since the EESSI stack is built with RPath linking, you kind of need to know where that you need to use RPath yourself and point to the correct libraries. And my idea was that as a user, I don't really want to know all of these things if I just have a simple C++ program, for example. And then the idea would be to basically automatically set up some wrapper scripts that do the right thing if you use the GCC binary command, for example, by putting the wrapper script in between and then loading everything. So, and this week I used basically a proof of concept setup where I at first just try to put the wrapper script somewhere and then load them in my path environment variable, so that if I want to use GCC, it's pointing to the correct thing and doing some magic. And the wrapper scripts are already produced in EESSI build, so I kind of just had to pick up this function and point things to the right place. And then in my example, it worked. And this is still work in progress. So you see two links here. One is pointing to a pull request for an EESSI blocks link where I try to rewrite the GCC core EESSI block. And this is basically loading the module, the module files, and or preparing the module files that the wrapper scripts are loaded in the right place. So this is still work in progress because you have kind of to rely on a couple of other things in the EESSI build framework, because the functions don't really have the right features right now. For example, the prepare RPath wrappers is putting the wrappers into the temp directory, but it would be much nicer if we could just give it a path where to install them. For example, if you install the module for GCC core, you could put them into the bin directory. And therefore, I've opened an issue in the EESSI build framework side of things. And in this issue, I'm tracking all of the things we thought about if we want to extend this feature set, basically. So, and the idea is to open a couple of small pull requests in the framework, put in all the features, and then in the end, in the EESSI block file of any compiler, we could then basically activate this feature. And by default, it would be turned off, and you could also dynamically turn it off by environmental variables. So if you don't want to have the RPath wrappers, you could disable them all of the time in many places. But if you want to keep them, then loading GCC would behave transparent. And I can also, I don't know if I should share my screen, but I can also show you an example where I did this by hand. It's a very simple example.
Yeah, go ahead and share. That makes sense to have a quick demo on this.
So you see my screen and you can read everything because, okay. So like I said, as a user, I don't really, if I do module load GCC, I don't really want to care about where the libraries are stored. And the idea is that if you load this compiler, you would basically just have in your path some line which magically appears that within the binary directory of the GCC module, we also have this RPath wrappers. And in this directory, we basically have, this is a directory of this module, and we basically just have the RPath wrappers for GCC, G++, and this is also a point of discussion where we should load the wrappers for LD, because in the EESSI setup, we kind of want to point to the compatibility layer, but in an EESSI build only world, we might want to pick them up from the bin utils module. So there might be to have some logic in the future to do the right thing here. But in this simple setup, it works because it's pointing to the compatibility layer. And when loading GCC core, I'm also installing the wrappers for LD at this point. So, and then I've basically just a hello world program, and I've compiled this once with a basic GCC core, and then with my change one, and you can see if I look into the output of the binary that in the basic one without the wrappers in place, it's basically picking up the shared library from the LD library path, but in the in my RPath version, then we see that, okay, it's picking up the GCC from my dynamically installed location here. And I also did a similar thing for a real program. So I have this MCF, what is it called? MCFM, which is some Monte Carlo simulation of some physics stuff. I don't know what the program is doing, but I know that I can clone the repository and then CMake and make install it. And here actually, I didn't care about anything of this, but I, in the end, wanted to see if I see my library path here. And it seemed to work out of the box. So this is from the previous version of my proof of concept, which is why this is pointing to the original CVMFS, because here I only changed the path library and didn't had a module which does the right thing now, but this already worked. And this would be basically the same thing. So from this, I would say that the proof of concept really seems to work. And the only issues still left to do are basically how to treat the AD library path, for example, and all of the functionality in EasyBuild.
Can you go back to your Hello World RPath binary?
Sure, sorry.
Because it seemed like it only had an RPath for the GCC libraries, but not for the compat layer. So the libc it's looking for, so lib standard C++, that comes from GCC, but the libc one comes from the compat layer.
Okay, so you would so we would expect this one to be picked up from the compatibility layer. Yeah, okay. If
you just do LDD on the Hello World RPath binary.
But I would suspect the interpreter is set in that program, so it would, by default, it would use the interpreter from the compat layer.
Okay, yeah, that must be because we're using the bin tools from.
So it's pointing to the right thing here.
Yeah, it's pointing to the right thing. Yeah.
Yeah.
Okay. Okay. Yeah. Makes sense. Cool.
Yeah, I mean, the important thing there is what the interpreter is inside. So what set is the interpreter? If it's the right one is set, then it's okay. Because even here, if you use that, it depends which LDD you use. Do you get the same result if you use the LDD? That's the LDD coming from the compat layer. Do you get the same result if you use the LDD coming from the host?
No, probably not.
Yeah, you do.
No,
you don't.
Well, you get the host, yeah, because it's not an RPath.
Because that's the LDD. So yeah, it's pointing to the right interpreter. That's okay. So if it runs as an executable, it's fine.
If you do file minus small b, no, file, just file, yeah, minus b for beast, yeah, and then the binary, it will tell you which which interpreter it's using. It's using the one from the compat layer, so that's good enough. Yeah. So that makes sure it's actually never looking into the host for libraries, and that combined with the GCC core RPath is enough to do the right thing. Yeah. Okay. Cool. Yeah. So it's clear we have a bit of work to do in EasyBuild just to make it very clean. In terms of how we implement it, but the idea of shipping the RPath wrappers in the GCC installation, that should work as expected. Good. I'll share well, maybe Bob, you should share your screen since you're going to do a demo as well.
Yeah.
What question? When you ship it in the GCC module, right? That's what you intend to do. Then it wouldn't work with other toolchains.
Well, we would ship it in GCC core, so in the base compiler.
Okay.
And I think that may be enough that it also works with other compilers that are sitting on top, like Intel or CLang or other things. But that's also something we should at least try, see if that works as expected. But if not, we can also wrap those compilers again. So any compiler installed with EasyBuild, we can install those same RPath wrappers in there as well.
Okay, cool.
So that's one of the reasons we want to do the changes in EasyBuild framework to make it as easy as possible in the easy blocks that we use for installing the compilers. yeah, so I would say overall for this task, that's a very good result. We have a clear path now how to cleanly support it. Bob.
Okay, then the next one. So Kenneth, Jörg, and I have been working on this task to make a workflow to add software to the EESSI stack through a GitHub app. So I'll tell a bit about the app itself. Jörg will tell a bit about the part that actually does the builds on the cluster, and I'll do a short demo. So we started this week with a very, very minimal setup of a code that Kenneth had prepared based on the code for the Boogelbot, and well, extended that a little bit during the week. Not as much as I hoped before we started the hackathon, but I think we got pretty far with at least extending it. So all the code for the bot itself, we put that in a separate repository on GitHub, so you can find that at this link. And what we currently have is a basic structure which can basically react to GitHub events. So basically for an app, you can define what kind of events you want to receive. If someone opens a pull request, closes a pull request, makes a comment, if a workflow completes, etc. So quite a lot of stuff, which you don't need all, but especially the pull request events are very interesting. So the most obvious one we've been working on the most is when a pull request gets opened, because that basically means that someone probably wants to add some software to what EESSI has. So something we don't have at the moment for our current pilots is that we basically now have a very rudimentary build script which just calls EESSI build lots of time for different EESSI configs. But probably at some point we want to switch that to an EESSI stack file, which will just represent the entire stack that we have. And then you can simply open the pull request as well, basically anyone. So then you open the pull request and just add a line to that EESSI stack file, which says I want to add this particular version of this software to the EESSI stack file. And when that happens, the GitHub app will basically receive that event, which says there's a new pull request. So we can grab the new EESSI stack file, put that on whatever system the app is running on. So it can be running on a login node of a cluster, for instance. And what it now does is basically will prepare some kind of job directory and fill that with an EESSI stack file from that pull request. And then it will fire off a build job to the cluster. Which will take that EESSI stack file, as Jörg will explain on the next slide, and basically start building everything that is missing in the current stack. So basically start building all the new stuff that was added to that EESSI stack file. So most of that functionality is already there. So that part is well, not done, I would say, but at least there's some kind of basic code that can already do this in some simple form. Besides that, we've been working a little bit on what's already mostly there, a simple logging function that will basically take the event data that GitHub sends and dumps that into a log, so that we don't need to open pull requests for every time we want to test something. But we've basically done that once and then grabbed all that data that's coming in, stored it as a JSON file, and there's now also some functionality in the app that you can basically pass a JSON file as some kind of dummy event so that you can easily test with that JSON file. That already works as well, as I will show during the demo. I've been working a little bit on authenticating the app. So as soon as you, for instance, want to put in a new comment in the pull request, you can't do that as an anonymous user. You have to authenticate the app, which requires a little bit of fiddling with keys and tokens, etc. But it also seems to work now. So if the bot is going to reply in the ticket, it will reply as a bot account, and you can clearly see that it was the EESSI bot which made that message. And finally, something that we wanted to have is that the app can basically run in different kind of modes. So by default, GitHub expects that you run this as a kind of web app with a web server so that it can push data to your web server. Which is kind of the default mode, but maybe every now and then you also want to run this as a regular kind of script, just a one-time thing, for instance, as a cron job that does this every 10 minutes. to check on the status of jobs that are running on your cluster, to check if builds are already completed or not, and well, if they are, that you can report this back into the pull request, which says, well, this build has succeeded or not. And this third mode, of course, where you can pass that that JSON file as an input. So most of this is now more or less done. You can find it on the repository. I added some new stuff today, which might not be in there, so I will do that later today.
Bob, a small question on the cron mode. Can't you avoid that by at the end of the job script, basically sending an event from the job script to the app? So just like locally?
Could probably also work, yeah, since it's running as some kind of web service.
So you could check if when you authenticate the incoming event, it should either come from GitHub and then match all the keys, or it should be a local event in some sense.
Yeah.
So that's maybe also something to try.
Could also be a possibility, yes.
Because then you'll have less delay. You won't have to wait until the cron runs again for the actual update to happen. That could make sense as well.
Yeah. So this is more on the front of the app, so how it receives these events and handles them. And Jörg has been working on more the backend where it actually submits jobs and starts doing the builds. So, Jörg, you want to say something about this?
Yes, so all of the scripts are on the GitHub page where the link is on the slide. Just go into the scripts directory. You will find quite a number of scripts. What I tend to do is instead of having one large file nobody can handle because you forgot what you've written at the top, I try to split it up in smaller files. So you've got the build files for the Singularity container I'm using. We are building in Ubuntu 20 long-time support, and we are testing in Woki 8.4. So if somebody wants to reproduce it, the definition files are there. There are basically 3 bash scripts which are important. One of them is called install.sh, which does the installation. A very similar one is called testing.sh, which does the testing in the Woki Singularity container. And all of that is basically fired off by automatic build.sh. So all you need to do is the bot needs to say, okay, sbatch automatic build and path name. And in that path, I expect the definition file of what you want to build. If it is called software list.yaml, it is an EasyStack file, and the script is handling it. If for whatever reason you don't want to use EasyStack, but you want to use basically just the name of the EasyBuild file, you can do it. It's called then software list.txt. And the correct submission scripts are then created on the fly. So the first bit is it is checking, do I have the EasyBuild version I want to have? That is defined in a global site-config file, where you also put in the path, and that is a little bit work in progress. If not, it is simply updating it, and that is working quite well. I tried it out on my test site this morning. It is simply updating it to the correct EasyBuild file, and then it is basically reading in whatever in, for example, software list.yaml is all installing it. It is printing out which modules are then available. Then it kicks over into the testing container. And here again, it is just using the, for example, software list.yaml and runs a simple, what is it called? Sanity test.
Sanity check only, yeah.
Yeah, sanity check only test. And it is basically checking if that comes back with correct. If it is correct, it's printing out parse, and then it is building, well, it is creating the tarball and the sharsum file of all of the software or files which are currently in that directory. That probably needs a little bit of tweaking. And if it is not correct, it basically stops and tells you failure. And in that submission directory, i.e. the one the bot is giving me. This is where you then will find the tarball. This is where you will find all of the scripts I was using, and you also will find all the log files from the queue. So by doing that, you can actually go back and have a look what has been done and where might be a typo or something like that, and can check it. And I think Bob is now running the test demonstration.
Yeah, I'll show that in a minute. Maybe first finish this last slide. So all the things that we haven't done yet. So I think we've
Can I just make one comment there?
Sure.
I know you do the sanity check only. It would be interesting to also run module only somehow as part of this as well, to make sure that if I regenerated the module file, that it would be exactly the same, or as correct, at least correct, right? And I think this is an important check as well.
Yeah, well, and I think York was just now running sanity check only because that's very easy to do. It's built into EasyBuild. Eventually, also, we want to run maybe the single node tests that we have in the Easy Test Suite. So we're building in a Ubuntu container, for example, and then running the tests in a totally different container. We do that on purpose because that's part of the reason why we're doing Easy, so it works everywhere. And yeah, we should run as many tests as make sense. So not for hours, but any test that we can run in the scope of a couple of minutes should be done in the testing phase of that build. And module only could be part of that because it's very quick.
Yeah, the reason I choose the sanity check only is it is quick. I don't want to spend hours on waiting for something which might happen, which is very thorough. For me, it was just a proof of concept. Yes, we can do it. And then you've got basically a path somewhere where you can trot along. And then the probably more time consuming tweaking starts to happen. And here you can think of, more checks, for example. What else do we want to do? At least what I already have in place, as Kenneth mentioned, we are testing in a complete different container. And I dare to say that Ubuntu and CentOS or Rocky are different enough to say if there is a problem, it should flare up.
Yeah, and one thing I didn't really mention here is that in the notes that we had for some kind of design for the app, we also thought about splitting it into even two more modes where you can basically run this app either as a build app so that it only accepts incoming build requests. So it will just fire off jobs to the scheduler saying, hey, build this app for me, this application. But that you can also run it in a testing kind of mode so that you don't build software, but only test it. And then it will just run the reframe tests that should become available for all these extra applications that should be added to the stack. So right now we only focus on building, but at some point you should also be able to run the app for just testing purposes. So then whenever an application was built somewhere, then your version of the app that runs in this testing mode will receive an event which says, hey, this app is ready to be tested. And then it basically fetches the tarball from, for instance, the bucket where we store the build, untars it to your local machine, and then runs the reframe tests on top of that application. And then it reports back to the pull request saying, okay, I have tested this and it's all fine. And only if all the builds have passed and all the tests have passed at that point that someone can say, okay, now everything is ready. So prepare this for ingestion.
Yeah, and that could also help if we make any changes to the compat layer. You could ask the bot, please rerun the tests for everything we have. So that makes a lot of sense. Yeah. Having one bot really to do everything.
We haven't really focused on that testing part yet, also because there are not really tests available. But yeah, that's going to be important in the future. So what we have right now is a very basic setup, which at least can fire off some builds. So there's still lots of work that need to be done. So the scripts that Jörg has been using were basically taken from his cluster. So we tweaked that a little bit so that it worked on the virtual cluster on AWS, but it doesn't really build on top of the Easy stack yet. So it doesn't build on top of /CVMFS. So that's definitely something that we still want to change, so that it can at least see all the things that EESSI already provides, and then start building the missing stuff also with the right EESSI settings, so that all the paths are correct. The EESSI build config is taken from EESSI, etc. Then we still need something that the app will basically detect that a build job is finished and can react, to, for instance, to failures and then report back to the pull request. The main functionality should already be there for reporting back, but it just doesn't really detect yet that a job has finished. So that would be one of the first next things that should be worked on. So also all the error handling, etc., that's not really there yet. Also the tarbles, it doesn't really do anything with that yet. So the tarball is being built, but it doesn't really take it and store it somewhere. Could probably go into a S3 bucket, for instance. Right now, we only focused on just one architecture, so that should also be extended to more. And for instance, that you on the app side can define in your settings, this app is capable of building for the following architectures, so that if someone opens a pull request, that your bot will start building for those architectures that you support. Then there has to be some kind of dependency flow for all the different kind of events. As already mentioned, for instance, first the build should start, and the build should only start if it was approved by an administrator, or if it's a trusted person that opened the pull request. And when the build has succeeded, then the test should start. So there's a lot of dependencies in there that something should only start after certain checks have passed. That's not really there yet either. And of course, it should respond to a lot more events now. It's only just the pull request opened events. But it can respond to, for instance, labels that are being set, or messages that are being sent to the bot. For instance, if something needs to be rebuilt, you might want to say in the pull request, hey bot, rebuild this for this architecture. That is something that isn't being done right now either. So let me quickly show you what happens if I start building this, or start running this. So what I will do, I will basically take some dummy data from a pull request opened event. As you can see, you get lots of stuff from GitHub about all the details of that pull request and who opened it, and etc. Right now, we don't really use that yet, except for finding the EESSI stack file that is included in that pull request. Let me quickly stop a job that I'm running in order to keep the node online, so that it doesn't have to fire up a new VM. So I'm just going to run it and send that pull request opened event as input to my bot, which will make a new directory in this job directory that I prepared, which has the name of the ID of the event, which is a unique identifier for that event, where it will put the YAML file, which is a very simple one for now, so that it completes very quickly. So it's just going to build bzip2. Let's check if it's already running. Yes. So there's a logs directory where it will create a log of what it's doing. This is just the output of the script I think it's going to run. So it's probably busy building now.
If you do less and then capital F to follow it.
The
idea was to basically print out what it is doing. And then you actually get what it is doing.
So I think this means it has already built and tested the software, right, Hugh?
It has tested the software, and only if the test is successful, then you actually build the tarball.
Which it's doing now, I guess.
Yeah. And also what I'm doing, that takes some time because we are using NFS. Also the file above, the Haswell SHA sum, that is where you get the SHA-256 sum of all of the files.
So that will take a while, but
yeah, that takes a while because we are on a slow file system. But basically, that was the idea.
Yeah, and I think when this is done, then that's it basically. So
yeah,
don't think we have to wait for that right now.
And as you could see from the log file from Slurm, it actually very clearly prints out at more or less at the bottom a path. if it doesn't pass, it says failure. So these are 2 keywords you basically could pick up and then act on it.
Yeah, and those are lots of details. We still have to think about how to send this back to the app or how the app should pick it up. But those were not that important.
I think it would be nice to send an event from the job script, send an event back to the app. Maybe even saying build done, testing started or something, so you get like updates and you can push them through to the pull request. That would be really, really nice. But that's already, let's say, nice to have. I think it's more important to try and complete the cycle. So have the bot build something, prepare the tarball, and then I guess do the easy upload thing to make it ready for ingestion. Or maybe that should only be done when the pull request is merged, or I mean, figuring out that workflow makes sense. And there's lots of tweaks and enhancements you can do to this.
What I don't know is how do I get information back from what I'm doing to the bot?
Well, you could create files that have like messages that the bot should just push back into the pull request. So like create a comment file, and whenever the bot sees a comment file, it would take the contents and push it back into the pull request. Or I think with a curl command, you can probably send a post event basically. So like GitHub does to the app, you could send it from the job to the app, and then the app would know what to do with it. So as long as you have network everywhere, I think you have network from the node back to the login node. That should work as well. That's maybe a bit better because then you're using the same mechanism for everything. So it's events flying around.
Yeah. So basically, what the bot needs to hand over, apart from the path name, it needs to hand over some kind of event identifier.
Yeah, so the data that the bot needs to figure out what's going on would be in the JSON that you send as the payload of the event. So very similar to what GitHub does.
Okay.
I think that would make sense, because then everything that you do in the bot or that you react to are events, and you don't have like file events or other events, but everything is coming in the same way. Makes sense, I think.
Yeah, that would even take away, as you mentioned before, the real need of having this kind of cron mode where you don't run as a web app, but
because basically instead of printing out paths here, which is an event, I could say curl and do something. If you see what I mean.
Or do both. You could still have the logging, but then also have an event next to that.
I think it is quite good to keep all of the log files and submission scripts, because in case things are breaking, then at least you've got the starting point, and not it's broken and everything is deleted and you're like, okay.
Yeah, and the cloud is infinite anyway, so we don't need to worry about storage.
I mean, you still could say, okay, if all of that is done and I copied over the tarball, and then I can say, I just delete that directory.
Yeah, or the bot could do that for you. And when the pull request is merged or closed, the bot could act on that and say, okay, I'll clean up the corresponding directory because apparently it's not needed anymore. Or it could archive it and then 30 days later remove it automatically, something like that.
Yeah. I didn't mean you personally, Kenneth.
No, but as much as we can automate, we should. So.
Yes, I agree.
Yeah, very nice.
Okie dokie. Should I continue sharing, or do you want to take over?
Whatever works.
Well, I have to do a demo, so I'll take over.
Okay, I'll stop sharing.
So, okay, so I think I gave my impressions already at the beginning, and I think it's maybe this thing in particular is, if you're coming from outside EESSI, if you haven't been familiar with what we're doing and things like the linker inside the prefix layer, This is maybe not the easiest topic to start into. And then the scheduling thing. So trying to schedule with people, and we have different schedules, and we were kind of starting from scratch with this. I mean, I had done it in the past, but documented nothing. So we were effectively starting from scratch. So there was kind of a pretty heavy reliance on me getting to a certain point before the people could contribute. But it was okay, it worked. So we got some things done. The GPU support, I would say it's there, at least, you know, the tests seem to be working right now. So I think that works. The final scripts, of course, are not in place yet. There's no protections on this stuff, and everything that we've done so far is RPM based, but we also need to be able to do the same for Debian. We also need to be able to pick up the tools that we need only from the compat layer. That's okay for Debian, so we need to be able to unpack Debian packages and RPMs. That's fine for Debian, but we'll actually need something that's not there, which is this rpm.e class, to be able to unpack RPMs. Or maybe we don't. I mean, if somebody knows a way around that, let me know. But I don't think it's a big deal to include this.
Can I just?
Yep.
Yeah.
For Debian, you can use alien, pardon me, because that can handle tarballs, it can handle Debian files, and it can handle RPMs, and you can convert it into something you want to have. So you can convert, for example, RPMs into tarballs or Debian files. I don't know if something similar exists for the RPM-based packet OS. That I don't know, but Alien is working really well on the Debian-based packages.
So all I need to do here is to extract information that's sitting inside these things. So if there was something that did both, that'd be great. But it's not really a complex thing. I basically just want to unpack them and take something that's inside out. And so it's easy with both of them is easy, but you need the right tools, right? So the Debian one, we already have the tools inside the compat layer, but the RPM we don't. I was pulling them from the OS, so it works fine, but we would need this extra package. And maybe there's something that would cover both, but it doesn't really matter, right? The tools are there. So that's really not the issue. It's just that we need to make sure that they're available in the compat layer and not relying on them from the host. Okay, and then, I think maybe it's already time to do the demo. I can show you how it works. So here I have, this is the samples that come with Cuda, right? So these are all the samples from Cuda compiled, and you can see that they don't work. So we'll take the device query one. It doesn't work right now, right? So I haven't installed the libraries yet. So we have our script, which is currently called working script, right? We can run that script and it does different things. One thing it'll do, it'll pull down the Cuda compatibility libraries. So I discovered that the Cuda compatibility libraries are basically all you need. So basically, as long as you're running like a driver that's 450 or above, all you need is the Cuda compatibility libraries, and then you can run any version of Cuda. So if you want to run Cuda, if you want to run the latest compute capabilities, you need the latest Cuda compatibility library. So it does mean that you have to have the latest version installed, but it will work. And then after that, then we install Cuda itself, so Cuda core in this case. That's just to actually, you have to have the Cuda installation, and then we just take one of the samples. So the samples are included in the EasyBuild installation. So you can just take one of them and run it, compile it, and then after you do it, you get the output, right? Tells you, this one was device queries, the one I'm using right now. And that runs, and then you get a little message saying, congratulations, it's working. And now we're still in the same directory. And if we go in here now, we run the same thing we ran before, it works. So that's basically it. And then you could run any example in here, at least all the ones that I tried, they work. So no, that's it. Seems to work. I don't think there's much else to say about it. It kind of works right now. It needs to be improved. Probably the scripting needs to be a lot improved. Bob, you have a question there? Or?
Oh, I was applauding.
All right, sorry.
Very nice work.
I actually have a question, Alan. So where does it install these compatibility things for Cuda?
So I was thinking about how to document this properly. I think the script itself might be the right place to do it. So we rely on our linker inside the compat layer. It looks in a very specific directory. So it's kind of, there's a trusted directory, And if you put these libraries in that place, which is what we do when we unpack the RPMs, it will just find them. So if you build something, so if you use this Cuda with a compiler that comes from the compat layer, it will use our linker. And because it uses our linker, it will find the Cuda library in the place that we put it. That's why all of a sudden it works right after I run this script, because I'm placing the correct library in the correct location, and the linker just finds it automatically.
So this is some custom prefix that we just define in the documentation. Look, if you want to install this Cuda, well, I mean, the script does it for you. It basically installs it in that custom prefix, right?
Yeah. So the cool thing about this is it's in user space potentially. So right now we use a variable symlink. So what we're actually going is into, it still looks like it's in CVMFS, but it's in this host injections directory, and that can point anywhere. Can also point to a shared file system, for example. But you have a path that looks like it's in the C. Huh?
You could put the host injections directory in user space. No problem.
Yeah.
It can be anywhere. Yeah, it's a symlink essentially, but like the other way around, it's a bit weird. But you can basically pick a directory and say the stuff in here has to match with what's in this specific location in CVMFS. So you can basically inject something into /CVMFS.
And that's what. By the way, you're allowed to configure your CVMFS client, because that's where you need to change the symlink if you want to. But by default, I think it points to /opt/easy or something.
Yeah. That's what we have right now. I don't think there's anything you can really change it to a default that's going to work out of the box for everyone in user space, right? So /temp maybe. Yeah, but well, it doesn't matter as long as it's user controllable. I mean, you can control this when you mount the client. So yeah. So I think that's the important thing. It's really one for the sysadmins, I would say, because you want to be able to control this a little bit, because I mean, if we go to the process of making the GPU modules hidden by default, unless you have the CUDA capabilities, you need to make sure that that only happens on clients where that's actually supported, right? Where there is a GPU or something like that.
And then if, because these compatibility libraries are also versioned, right? They get newer versions every now and again. Like, do they need to be updated, or what is the, how do you check, okay, they're maybe already there, but maybe I need to update them?
Yeah, so we will do that too. So there's another script in there that checks for the latest version of those compatibility libraries, and it needs to know a number of things. It needs to know your operating system version, and then your general architecture, right? And from that, it can figure out it'll list a load of RPMs on a page, and then figure out which one is the latest one, and install the latest one. And the thing is, you always need the latest one. So the thing is, all the different versions of well, you don't always need the latest one. If you want to use CUDA 11.5 or whatever, you need the latest one, right? But anything younger, anything older CUDA versions will all work with that CUDA compatibility library, right? So it's the same as a driver, right?
I'm just thinking, like, what will be the procedure if, let's say, we as EESSI decide, okay, we're going to install Cuda 12, which is not there yet, right? So somebody who's installed the compat layer before, or the compatibility modules for Cuda before, will have a too old version of these compatibility things, right? And then somehow they will need to see, hey, now I'm trying to run something with Cuda 12, that doesn't work. I need to rerun this script that installs the newer version of the compatibility libraries, right?
Yeah, so basically I use the same kind of system that that LMOD uses, right? So what you're actually what everything is pointing to is latest. And then I just change the symlink of latest. So basically every time you upgrade, everything in the past will get upgraded too, as long as they're using the same process, right? Yeah. So basically, if we get a newer release of EESSI, you need to install the latest CUDA compatibility, because you'll need it to run the CUDA anyway. Yeah. But then this will automatically update everything else as well. So it's kind of transparent.
Yeah, that's true. They also need to reinstall their own new CUDA core, of course.
Yeah. Like, so there's always a step. Yeah. If there's a new release, there's a step anyway. So you'll need to run this script, and then we can handle it in there.
Yeah, no, makes sense. Okay, clear.
I think this whole setup, I mean, this works, right? But it's still annoying. And how much of this could we avoid by being allowed to ship Cuda itself in EESSI? Not everything, right?
You only need the compatibility libraries.
So that part we're always going to need, no matter whether we can ship Cuda core ourselves or not.
So the problem is you can't escape from it a little bit, because even if you put the Cuda compatibility libraries into the compatibility layer, right? So if we just copy them in there, right? It doesn't save you if somebody updates the local driver, for example. So if you're running an EESSI layer that's older than the current driver on the system, it won't work. It'll complain about something, right? And so then the whole thing doesn't work, right? Whereas if you had the ability to update the compatibility drivers, it would still work and everything would be fine.
So that part should maybe always be, client side.
And then, the one downside of having to install Cuda core, it takes space. That's probably nothing for a cluster. It doesn't mean anything, right? But if it depends where you're installing it, right? You need about 16 gigabytes of space, because you need kind of 3 copies simultaneously. You need you need the sources, you need the build location and the installation. And at some point you're going to need all 3 at the same time. And they're all about like a few gigs each, right?
Okay. So yeah,
you can get around that. We could get around that somehow. But
yeah, but that's still a good argument to step to NVIDIA and say, look, we have this, it works, but it's annoying for this and this reason. And can you please help us make this as frictionless as possible?
Yeah, it would save people hassle for sure. Mm-hmm. Then you'd still be left with the compatibility thing, but it'd be very small script at that point, right?
Mm-hmm. Yeah, and that's probably, like you said, it's too much tied to whatever driver you have on the system. So you probably want to keep that anyway.
Yeah, the script would give us the opportunity to sanity check things properly. You need to do that. So.
Mm-hmm. Yep, cool.
What's left to be done? So we thought about this idea of tagging every build that either is Cuda or needs Cuda with an LMOD tag, and then the possibility of hiding everything that's tagged like that by default, unless some condition is met, right? So whatever that condition might be. Turns out, War just told me now that it's actually not possible to hide things based on properties right now. So, probably Robert would support that, maybe. I don't know, we'd have to ask him about that. And then that would make us require a later version of LMOD, but that's also okay, perhaps. And then the other thing we need then would be this symlink in CVMFS. So to actually transparently use this Cuda installation that we have. So basically symlink where instead of, the path would look the same, right? You just make a symlink from the versions into the host injections. So basically put things in the right place and have a standard symlink in place on CVMFS to point to that. And then it would just work. And then, you probably want some guards inside that module file, right? To make sure that that module can't be loaded unless the installation actually exists.
Plus, we need some kind of mechanism to actually build the Cuda software, but then not put the Cuda installation in the tarball that you deploy on CVMFS, right? Yeah,
but we can have some kind of cleanup phase after every build that makes sure that we never ship Cuda.
Yeah, but something that needs to be built. It's not completely trivial.
Throwing away a directory is pretty trivial.
If you know which one to throw away, yeah.
Anything that has Cuda in the name. Yeah.
You could just one thing you could do is change your CVMS configuration to point somewhere else, right? And it would just disappear. The other thing is you could just delete everything underneath host injections, and that's it. It'll be gone. Without being very specific about what you're deleting, right? Just take everything out before you do the tarball.
There's a little bit more homework to, let's say, make this clean, but yeah, it's clear that we can definitely do it. That's very good. All right. So yeah, I guess next steps here, Alan, are somehow adding this into our whatever build script or thing that we're going to use to install software.
Yeah, it needs to be fine-tuned. It needs to be tested on a Debian system as well. I just don't have the Debian stuff for extracting the Deb packages in place, but that's easy. And then, yeah, you just need the logic stuff. So figuring out, we have some of this in place, but we just need lots of little small checks, right? Details.
Hmm. Yep, cool. I guess, Kaspar, you can take over.
Yes, let me share my screen.
I think you're also planning to demo something, so.
Yep. Yeah, so first again, hackathon impressions. I was very happy with the test clusters. That was very well organized. It was easy to get access and easy to get the work there. Again, I think the small teams were good. I think that works well. In our task, I noticed, writing tests is still a pretty individual task, so there was not a ton of interaction. I did have a good session with Hugo on Wednesday where we looked at his WARF test and he looked at my test at some point. So that was useful, but I think there could have been more interaction in the end. In terms of achievements, I mean, we didn't get as far as I hoped we would get, but I guess that's often the case. But we did create a list of the required and desired tests, looking at the software layer we have right now and the compat layer that we have right now. We didn't really have a good overview of what was missing, and I think we have a pretty decent overview now in our HackMD document. We also agreed on which test labels to use. These are things that are going to be useful when you want to select tests in order to run a subset of the test suite, which is essentially what we want to do in the CI. I personally worked on the GROMACS test, which was written on top of the library test that CSCS made. So basically, I wrote an easy implementation for that. And there's a PR for that now. So the only thing is that, okay, Hugo did have a look at it, but he didn't officially review it. Like somebody should comment something in the PR and say, hey, this could be different or this could be better. And then I think that's ready to merge. Hugo worked on a WARF test, so he also worked on the WARF installation on top of EESSI, right? And he also created a test for that. That's still in an initial version, let's say. It does work, but it now downloads the input files, which are very big from some remote location, which is not very fast, so it takes forever. That is something that will come back on the to-do list, how to improve on that. But at least it's a start, right? It's something that in principle runs and works. And I think also for Thomas, who also participated in this task, I think not everybody was familiar with Reframe yet when they started here, and then it's a pretty steep learning curve to really get into these tests, because yeah, writing portable tests is not the most easy tasks, so that takes some effort, and I think the task members at least gained some experience with Reframe, so I think that's a good thing. Then regarding the issues that we hit, so the first thing was that with this GROMACS test, I hit an issue which was due to SA Linux, not allowing me to copy some file because of security things. I reported that to the developer of Magic Castle, and he took a look at it and probably solved it, but I guess that, yeah, that will only start working once we re-roll out a new Magic Castle cluster. I also worked a little bit on the TensorFlow tests. Like there is a CSCS library test for it, which uses the default Horvath example. The problem is that that has a few limitations, like it doesn't properly support CPUs. It will just do single-threaded stuff. You can't run pure TensorFlow. You will always need to have Horvath installed, even if you just want to run on a single node. So I'm considering, I think we should still ship our own test for this one, where we basically adapted the Horvath example to support those two things. I tried that, but on the Magic Castle, I still don't manage to run with multiple threads. Whereas if I run the same test on my own system, I think it works, but I need to recheck that since I made some changes. Regarding the to-do, we need to actually integrate these tests in the pipeline, right? So as I will show in the demo, we now have a single command, at least for GROMACS, to run the GROMACS tests or the CI subset of those tests. And that is something that could be called from the CI pipeline. For WARF, as I mentioned, we need to find some way to efficiently handle large input files. You don't want to download them on the fly. One option would be to ship them with CVMFS. Another would be to just put them somewhere on a faster location and download it from there on the fly. That's another alternative option. In principle, Reframe has support for this. Like you can specify or in your configuration script a resource directory where you keep these larger files. So yeah, if we would ship them in CVMFS, it would be pretty easy. You just point the resource there, and then you can use inputs from there. But that's something we still have to do. As I said, the WARF test is not in a final state yet, so that needs to be finished, and then a PR needs to be created. It is checked in now in the hackathon GitHub. We also need to document on how to actually run the tests that we do have. I will show you in the demo, and it is in a HackMD document, but that might not be the easiest place to find if you really need to, or if you really want to get going with this. And one of the things we thought about when we discussed within the group is that, yeah, we see a lot of other groups now implementing new features, and we made this list of what do we need to test, for example, for the compatibility layer. As soon as you add new features, you also need to make new tests for this. So for example, the GPU support, that is something that is very concrete where you could say, yeah, we also need some way to test this GPU support. And that's actually pretty difficult. Like we as a test suite group, we don't know precisely how the GPU support works, right? So you need to somehow work together on that. And then, of course, there's a lot of tests on the list of tests that we need to create that haven't been done yet. As I said, we didn't make as much progress as I had hoped initially, but we did learn a lot along the way. So for the demo, let me just start clean. And I put essentially the commands that I'm going to run now, I put them also in the HackMD document from our task group. So if you want to do this yourself, you can. I will just paste a ton of commands here just to check out the relevant repositories and check out the right branches of those repositories.
Can you increase the font a bit, Caspar?
Sure.
Also for the recording, I think that makes sense. Yeah, thanks.
Is this enough?
Yep.
All right. Then we need to set a Python path because we actually use these library tests, and the library tests are just Python import statements. So it needs to know where to find these. And actually we add two locations. One is for the library tests that come with the Reframe repository. And the other is that we add a subdirectory of our own software layer where we have some utility functions that we use in test, because there's a lot of things that you want to repeatedly do. For example, for pure MPI tests, you generally always want to set the number of tasks equal to the number of cores. That is such a standard procedure that it's nice to just be able to reuse one function in every test. And once we've done that, we can, for example, list the tests. We're now looking at the GROMACS branch, right? So we'll see a list of the GROMACS tests that Reframe finds. Basically, the Reframe command consists of, well, you point to a configuration file. That configuration file describes your system. That is the only thing that an end user will have to actually change or set, because you need to define which partitions do I have GPUs in those partitions, etc. So that's the thing that the end user will have to configure. I made a configuration for this Magic Castle instance. Then you pass the directory where you want to search for tests. So Reframe will recursively go through that directory and find Python files where there are tests being marked. So there's a, how do you call this? I forgot the name, with the @ in front of it. If you tag a function or a class, a decorator. Exactly. So if you decorate a class with the right decorator, that's how Reframe says, okay, this is a test that I need to run. And then with -t, you can specify certain tags. So that is for test selection. In this case, I specified the tags CI and single node. So this would be something that you could run on the build node, the set of tests that is returned right now. And with -l, you just do a listing. If you do -r, it will actually start running those tests. And as you can see, it comes back with 4 tests. The name, basically Reframe generates a lot of tests automatically based on parameters. So if you have a GPU and a CPU variant and you have multiple modules, it will start to create all of the combinations of these. And that's also what you see here, because we have 2 GROMACS modules in this version of the EESSI repository. We have 2021 and 2024. And for each of those modules, it will generate 2 tests, namely a version that puts the so-called non-bonded interactions on the CPUs and a version that puts them on the GPUs. So in total now we have 4 tests that are being generated. And if I run these, you will see that it finds, oh, I skipped 2 tests. Why? Because these partitions don't have GPU in them, and these are GPU tests. The other 2, it will start running them. They actually take 5 minutes, so I'm not going to wait for them to complete. But if they complete, Reframe will just tell you, hey, this was a success. And you can also ask for the performance numbers if you add performance report. We don't do any performance checking right now because on a generic system, you don't have a proper reference. But at least you could print what the performance is, right? So it will tell you something for GROMACS, like how many nanoseconds do I simulate per day. If I remove, for example, the CI thingy, or I change it to monitoring, right? These are 2 of the tags that we agreed on within our task group. If we switch to monitoring and I remove the single node, you will basically see all of the tests that are in there. So there are 6 different use cases, I think, in the standard GROMACS test that comes with Reframe, and it will start to run all of these for the combination CPU, GPU, with all of the different modules. In the end, I actually meant to list them, not run them, but in the end, you end up with 96 tests. So you see here, it found 96 checks. And again, it will find out, do I have GPUs in this system? No, then I will skip all of the GPU tests. So you will find that half of them are skipped. We also agreed on a tag that defines the amount of nodes that are being used, more or less. So we have a small, medium, and large. Small is just 2 nodes. So that's sort of the minimal that you need to test multi-node stuff. Medium is something like up to 10 nodes, and large is anything above that. In this case, we're on a virtual cluster that only has 4 nodes, so you could use the and small tag to only list the multi-node tests that are on 2 nodes. So then again, you have a way to get a subset of those tests and run them. And that's about it, I think.
Is there any way you can get rid of the horrible test naming? At least when you list the tests, that Reframe tells you this thing with all the underscore and that takes 1,000 characters. Can you like map that to something human readable, or
like the naming? Naming of the tests?
These are just insane, but
they are pretty insane. I think it's something they're looking at. Like, can we make that more, more readable? The difficulty is that because Reframe generates all of these combinations automatically, right? And it puts all of that information in the name in some way. Yes, I can overwrite the name, but I don't know if that's going to be a better solution.
No, probably not.
The advantage is if you know how it works, you can actually see a lot from the name. Like you can see, okay, this is the variant that runs with the non-bonded interactions on the GPU. It has this tag. This is the name of the use case that is being used. It's running on this. This is the system name. So, okay, here that depends on your Reframe configuration file. It has the partition on which it's going to run, the software environment with which it's going to run, and then your module name. So yeah, there's a lot to it, but it's also sometimes useful.
It's better than, let's say, a hash, which some other tools are using.
Exactly. Yeah, because otherwise you would also not be able to tell them apart, right? You wouldn't be able to tell do I get the right subset of tests that I expect?
Mm-hmm.
Are the test names consistent between runs?
Yes.
So, and they're consistent across everything, right? Like versions of Reframe and everything.
Yes, although, well, as I said, they are looking into, how this is formatted. So they might come up with something with fewer underscores or something like that. So in that sense, it might change a little bit, but
yeah, because I'm thinking if we, just to keep tags on what's what, it would be very handy if they didn't actually, if they were predictable at least.
Yeah, not sure how long that's going to be the case.
Oh,
that's something.
Yeah, I think it's very good. And so you've mainly played with this on Magic Castle?
Yes. Yeah.
So redoing this on the other cluster, well, that's a heterogeneous one, so that makes it maybe a bit more tricky. You would have to also tell Reframe to only submit to a certain type of nodes.
Yeah,
but
so essentially you have to specify, in reframe you specify sort of virtual partitions, right? And these virtual partitions should be homogeneous things. So even if your system partition, if your Slurm partition has multiple types of nodes, in the reframe partition you could say, look, I don't know, suppose you have one CPU partition, but you have AVX 512 and AVX2 CPUs, and your access mechanism is to pass a constraint for that.
Yep.
Then in reframe, you would define two virtual partitions and say the way to access partition 1 is -p CPU -- constraint equals AVX2, and the way to access the second partition is same thing, but then with the AVX 512 constraint.
That's exactly how it works in cluster in the cloud. Yeah, you specify the shape of nodes, so what type of node you want. So that will work well. Yeah, nice, very cool.
Yeah, so you can give it a try if you want to. The only thing is you will need to install the newest version of reframe in order to run some of these tests, because they use some of the newer features, but that's easy to do.
That shouldn't be very difficult.
All right.
Cool. What's next?
You can share the slides at least.
Monitoring. Are you going to show anything?
Well, I was thinking of showing something.
Then why don't you share the slide?
Oh, then I have to find the slide somewhere else. Hold on.
Oh, well, I can show them and you can switch to.
Yeah. Why don't you do that? I'm trying to set up browsers and I have 10 billion tabs.
Yeah, there we go.
Main lesson is that I'm still keen on buying some time from somebody. If anybody has, 10 hours a day to share, then I'm more than interested in buying some. The good news is that the team was basically me. So apart from my teammates, it was a good job. They were morons. We got monitoring up and running. That means that every Stratum server can ask to have a local stack of Grafana, Prometheus, and Node Exporter, and a preliminary CVMFS support. I'll show this actually in a demo. This is all pushed by Ansible, and the roles, they're pushed by Ansible roles. So essentially in your Ansible setup, you say that I want this node to now have these services added to it, and that's that. There's some local configuration you can add, but it's fairly simple. Very, very clean. You don't have to clone any repos or anything. The Cmvs integration is still a bit wonky because getting Cmvs installed on a machine that's already being managed by Ansible means that you're having two colliding Ansible setups trying to collaborate each other a bit. So you need to kind of merge them a bit. I've looked at ways of doing that, and it's kind of worked, but we will see exactly how well it hasn't worked. Yeah, the big thing for me with the hackathon model is that it actually got me to set aside some time, which was very, very good. Currently, the main issues I came across was that the Ansible setup from EESSI is based on repos. You're supposed to clone repos and run things from them. This means that if you already have existing setups, you end up with like, okay, which inventory file do I use? How do I share inventories between them? How do I share host classes? How do I share all the other typical thing that somebody might manage an entire fleet via Ansible already have? That becomes a little clumsy for people when they set up a Stratum 1 because they might have other things already managed with that Ansible environment that they're working with then. This was the case here because the Ansible environment now is managing a lot of things that aren't easy, directly tied to EESSI, like Grafana and all this stuff. So adding EESSI stuff meant either clobbering the config or copy pasting stuff. Mostly gotten around that. I've worked on a set of Ansible roles that are essentially the same as we see from file system, the file system layer, where you can essentially say that this node is supposed to be a EESSI Stratum 1 node. And you give that as a role, you give it some config in the file, and it will pull that down from Galaxy and run it, and you will have a Stratum 1 server. That bit doesn't work perfectly well. Again, we're going to see that. And it probably needs to be migrated to the modern way of shipping multiple roles within the same group, which is a collection, Ansible collection. I'm not precisely sure whether or not we should distribute each Ansible role. So we have an Ansible EESSI Stratum 1 role and an Ansible EESSI Stratum 0. and such, and have them as separate repos and have them share a configuration repo instead. There are a couple of ways of doing that depending on how we want to think of whether I'm going to ship like all of the easy Ansible stuff as one big blob, or put it in separate repositories where there are some interlinked dependencies. The idea would be that the core repos is the stuff that others depend on, and the other repos are very, very thin. I'm going to test both and see how it actually works out. That bug I found was fascinating. That's actually what you got back from running Ansible when it was trying to fork itself. I don't know about you, but I see Objective-C weird crap like that in the middle of my run. I'm assuming my machine has suddenly decided to kill its own memory or something, but no, that was a known bug. So you can disable the initialization of fork safety, and that clearly works. I don't know why, and I don't care. There were some interesting conversations on GitHub that I read, and I had this feeling of why, and then moved on. Another thing that came up is, what on earth do we do with private stratum ones that don't have internet access? Like, how do you pull down dependencies from Ansible? How do you push things to them? How do you, generally speaking, make stuff work?
How can a stratum one that doesn't have internet access work at all? Like,
yeah, I mean, you need to get a Cmvs clone to begin with. I mean, at some point, either somebody's running around with a lot of memory sticks, or you give it internet access during install, and then you cut the pipe afterwards.
But it needs updates from stratum 0. That doesn't work.
Oh,
right?
no, I've run into people who are clear on the fact that they want a stratum 1, and then they want to cut it offline, and then they just have what they have, and that's fine. I pointed out that there's occasional security patches, and their response was,
but I don't think we should really care about it. I mean, if someone wants to do this, which sounds like not a very good idea, then
let them. Yeah.
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 If you want to shoot yourself in the foot with a bazooka.
So basically, the thing I've done so far is say that the way I've defined private stratum ones is that they only allow connections from specific subnets. That's the definition of a private stratum 1, but it's still online and functional the way we think of a stratum 1, except that it's not part of the shared pool, and it is not connected. You can't connect it from anywhere in the world. Interestingly, as Bob noted in the Ansible files, you still have to give it a geotag, even though nobody will ever or you should never actually use that geotag for anything. Fascinating details. And again, with the issues, the CMFS monitoring dashboard, it needs a little bit of help. It's been a while since the people who made this stuff have actually updated it. So yeah.
But the geo API thing, that does make sense a little bit. I mean, if the private stratum 1 goes down, you still probably want your clients to be able to connect to a different one. And then it's useful.
The problem is that for a lot of people have private, yeah. As well, if people have the private stratum 1s and private proxies, their clients can't connect to anything else because they don't have net access to anything else.
That's not necessarily true.
Yeah. No,
but I mean, some places will have it true. But anyway, they always need to have the API key or the geo API.
There is a way to disable that, but I think the CVMFS developers also said that they highly recommend to always use it. Otherwise, you can get weird errors or something.
Yeah, but it's fine. I mean, it's worth having in the back of your head, or in front of it, depending on how hard you would bang your head. Kenneth, next slide, please. He's trying. Thank you. I got very, very happy with the Cloud Academy and a couple of other resources for reusing roles from Galaxy, or actually GitHub directly, rather than both cloning things or developing things myself, and seeing that things could be adapted pretty well. I took a lot of time going through the Cloud Academy setup for Prometheus, Grafana, Node Exporter, and noticed things like they actually have SC Linux, which is actually supported internally in Ansible because it's shipped by Red Hat, which means that they actually have SC Linux modules. So you do things like you enable ports and you enable binaries to run, and you do all that kind of stuff, and you have SC Linux context managing in Ansible. So in all the things that are being pushed to our Stratum setups and the stuff like that right now that I've worked on, this is actually taken care of. So that's kind of cool. And it also, of course, checks that you're on the right platform. It doesn't do anything if you don't have SLNX and all that jazz. If you look at the role Kenneth, if you click on the Cmvs monitoring link, you will see that we have a similarly styled thing. If you go down and see how you call it to the bottom there, which didn't actually, yeah, it deploys the Prometheus exporter, and all you do is essentially tell that you're going to have a role. And I see that I didn't upload the documentation for how to use it. That was fancy. But we'll see that in the demo as well. So you end up with a structure that is very nice and tidy and clean. There's almost no, there's not a lot of like local config or local stuff like that at all. It just takes care of the things you have to do to be able to function, which is really, really nice. Let's see, I'm just going to go find something here. There we go. Oh God, how many Safari windows do I have again? There we go. Right. If you look at the monitoring branch, yeah, this entire thing, the inventory is the test server I have on AWS. And amazing enough, the only code that does all this work is this. Because all I do is I say, hey, I want to take these roles from Galaxy with some configuration for each one of them and deploy. This is the one I ended up writing, which is, there's a lot of small things you have to do, like things for SLNX, opening ports and stuff like that. But the fact that it's all distributed into the role means that you can very neatly have it, you know, abstracted away. Also, the thing that was cool with that is in the requirements file, you can do stuff like this. You can say, I want this version, or I want this version from this branch. So we can basically update or test or do whatever you want and have a little bit better control over how you actually deploy your roles. Now, when this is all done, it takes a bit to run, and I'm not going to run it from scratch because it does honestly take a while. You end up here. You log into Grafana, which, by the way, I'm guessing best practice is doing this, isn't it? This is how things are done. Oops. But there's a way of setting that in a nicer way, but that means that Grafana won't ask you the first time you log in to change the password. So when you do that, you automatically get this, which is kind of neat. I mean, it's semi-useful at least. We have memory usage, network bandwidth, and it does actually work as proper Grafana logging and everything. This is currently only kept internally. It is not exported out to a central server, but that's not actually too bad to do. Now, I did mention that the Cmvs thing isn't quite as good as we would like. It does this a bit. For one thing, the cache usage is probably not correct. The PID is probably also, I don't know. I mean, last time I checked Linux PIDs, they're usually an integer. I'm not exactly sure why it's this. There are some small things that need fixing, but you know, it. And these dashboards, by the way, they're deployed during the Ansible push. So if you update the dashboard and you know, in the repos and you push the Ansible role again, it updates the dashboard. So these JSON files are pushed directly, so it's not no local management or anything. They're static. They're not even, you can't even edit them. Well, you can, but they won't actually be stored. So yeah. That seems to have had some positive effect, and there's a lot of things one actually wants to try to learn from this and actually develop on. If you can go back to the slides, Kenneth.
Sure.
Thank you.
So the idea is to easily have this monitoring added to the Stratum ones that are deployed with our Ansible playbooks, and then also to have it like a central monitoring server in, I guess, AWS or Azure, doesn't matter, that pulls in all the
The scraping is done by Prometheus, which then pushes data. That's the backend database, which pushes things to Grafana, that displays it. And the idea is that for public Stratum ones, at least, they will allow the monitoring node from monitoring easyinfra.org or infra-easy, whichever. DNS is hard. To go and fetch that data. So it'll regularly just pull that data from each of the Stratums and make a consolidated dashboard. That's the next phase. I think there's some, if you look at the to-do list that comes up next. Thank you. I need to fix the CMFS monitoring because I don't think it's quite there yet. Depending a little bit about what you want to know.
Showing stuff.
It's doing some stuff. We should also make the file system layer install be role-based. I would ideally like it so that you can say, like you did with the rules for saying that you want to get a file and stuff, to just say, I want easy Stratum 1 on this node, and it gets pushed. And you can set up some of the config. That is mostly done. There's some small little hiccups of getting it to work properly and see if I need to migrate it to collection stuff, but that's getting there. We should also decide on a naming scheme, because these Ansible repos will probably have a few of them, and decide how we want to name things. Currently, I've named them Ansible-easy- kind of purpose, because it distinguishes them from both for internally for us, what they actually do, and also for somebody who looks at them at Galaxy or something, that they actually related to easy. Same thing goes for the roles, but that's less of an issue. I mean, Stratum 1 is a nice name for a role as long as we scope it within the easy namespace. By the way, if anybody ever checks Ansible namespaces, the dot is just not a character. It's just a convention. So, you know, don't think too hard about that. So yeah. Any questions?
No, it looks really cool. You made a lot of progress here. So other than the obvious issues with the CVMFS dashboard, I guess if those are weeded out, we could start looking into the existing Stratum ones. Well, we fully control two of them, the AWS one and the Azure one. So maybe setting those up first and then letting those push to a central monitoring server, that could be a good way forward. And then once that's set up, we could look into the Norwegian and the Stratum 1 in Groningen, and maybe also the Stratum 0 to push stuff to that central monitoring.
Yeah. No, I mean, the Stratum, there's also some stuff ready for Stratum 1 and Stratum 0 as well. What I would like to do is make it so that the repo we today have as a file system layer, or something similar to that, essentially is an Ansible repo that is the configuration repo for our infrastructure. Whether we put it in the infrastructure or we put it in file system layer, how we do it. I mean, just so we have, like, we have roles that is consumed by ourselves to configure the nodes we have out there. So we have a fixed inventory file that we go and run changes to. So that when we make a change, when we make updates for configuration or something, we essentially edit the Ansible repo we have centrally, and we run that, and then it gets pushed. And any changes are taking place out there. So we actually run our infrastructure. Yeah.
Cool. Yeah, very nice. Any questions on this or comments or? No. Okay. Yeah. You did this mostly by yourself, Terry. I think there's a lot of work behind this that we probably don't realize, but yeah, looks
there was a lot of let's people like to call it learning.
Learning, okay. Yeah. Learning by swearing.
I mean, this is basically, I was doing this on my own this week, and it was a fair bit of work. My team was no help whatsoever. I mean, honestly, but the main thing is that honestly, a lot of this, there's a lot of moving parts and things like Ansible. I mean, there are 10 million ways of doing things, and people do it 10 million different ways. And every time you try to figure out what's smart, it's changed because, well, yeah. So, but yeah, go for the.
Yeah, I was just going to say, if this has matured a bit, so if we indeed have something where we are monitoring stratum 1s like this and pushing to a central server, maybe this is something you should show at the next CGMFS user meeting.
Yeah, I think it's a bit more than what they have on their web page monitoring stuff.
Yeah, it looks like this could be interesting for other CVMFS sites as well.
I also like the fact that we get CPU load, we get the IO stats, not just from the CVMFS, but like the entire system data from the node exporter. There's tons more data that isn't there, and we can create our own dashboards, and it's pretty easy, very easy actually, to just make dashboards in Grafana, save them as a JSON file, put that into our repo, and make sure that, and on the next push, that JSON file gets just pushed into the config.
So whenever updates are pushed into the GitHub repo that has the Ansible stuff, it gets automatically picked up by all the Stratum 1s running this, or
you have to run the playbook.
Okay, but you could run that in a Chrome or something like that,
or you run it as a post commit if everything's gone fine.
Yeah.
So it's actually it's really, really nice once it actually starts flowing. It's just it needs a bit of cleaning, and we need to clean up some of our old Ansible stuff.
Right, very nice, cool. And then I guess it makes sense to have this task next. So the private Stratum 1, I think, Bob, you're gonna explain this. I'm not sure, is there a demo involved here? Probably not, or?
I didn't prepare anything. I also see that Ahmad is online. I don't know if he wants to do this.
Yeah, there's not much to demo, I think. Just we went through the steps, and Axel made us some documentation, so there's not much to show here other than just saying what we found out and what we learned.
So there's some changes are already merged into the documentation. I think it's mostly Axel who did this, and there's a follow-up pull request as well, which maybe focuses more on the client configuration.
I think he made some minor additional fixes to the Stratum 1 page, but indeed also started working on the client page. So describing how you can configure your clients with Ansible or with the packages or with Singularity.
So basically everything, Ahmad, you guys ran into when trying this is now being documented properly in the documentation, and there's lots of notes here in the HackMD as well, right?
Yes, exactly. I think I can even some of those things I could even add to the main documentation. I can make a PR for that. I'm not sure if all the things are already in there, but I'll have to sync up myself with that. Didn't have time for that yet, but most of the notes that I made for while I was setting up are in this HackMD file. Exactly.
Yeah, I think Axel is pulling some of that stuff out of the HackMD and pushing it into the documentation.
Great. Yeah.
And there's also a part here, a subsection about how you can run test commands. I'm not sure if those are being added to the documentation, but something that could also make sense is to have Reframe running those checks for you, right? So if you set up your private Stratum 1 and then you have a client that is supposed to be configured to connect to your private Stratum 1, we could probably have a Reframe test script that verifies whether everything is working, whether it's actually talking to that specific Stratum 1, and so all these checks that you have documented in the HackMD.
Right. Yeah, that would be cool. Yeah,
that could probably be automated as well. Yeah, could be very nice. All right.
And I see there's a point here mentioned about the instructions on how to put the snapshot in a non-default location. Like I made this point, I actually had a question about this. I know it's possible from the CVMFS Galaxy role that we use in the Ansible script, but I wasn't sure if this was exposed yet to the EESSI YAML file. So I can add this instruction still, but I don't think they are there yet. That's just what I'm not sure if someone else added that or not.
I think it was part of the PR that Axel has already made and which was merged, I think, today.
Oh, really? Okay, I couldn't find it there, but maybe that's that I didn't see it properly then.
But I'm not sure. I think there were two different ways where you can do this. There's a I think two variables in the Ansible role which somehow control that location.
Right.
But I'm quite sure that I saw something about this in the current page that Axel updated.
Yeah.
But yeah, to be sure, just check it, and if you think it's wrong, then open an issue or a pull request.
Cool. Yeah, I think this is a really nice thing to have, also, especially for having Strata ones in the cloud, on cloud instances, where you have a lot of times you have persistent disks that are kind of separated from a VM itself, and you can detach a VM from that disk and reattach it later. So
yeah,
having this Strata 1 snapshot on a persistent external disk would be really cool, because then if your VM would crash or have some issues, you would not have to re-download the snapshot. You would just have it on the persistent disk.
Yeah.
Yeah, that makes a lot of sense, especially once the repository becomes bigger and it looks like we're well on our way to making it way bigger. That will become very painful if you have to re-download everything.
Yeah.
All right, cool. Yeah.
And we may have to go through this again whenever Terry is done with rearranging the whole playbook structure. That might work a little bit different from what the documentation now says. But maybe then would also be a good time to try and see if we can add some easy mechanism where you can maybe switch some Boolean flag or something in the Ansible settings, which says that this should be a private stratum 1. Because I know that you ran into quite a bit of issues with setting that up properly, and it's quite error prone if you, for instance, that colon or semicolon thing that you had, and suddenly it seems to work, but you get very weird behavior.
Yeah,
so it would be nice if we could automate that a little bit more from the Ansible side.
Yeah, I can help with that for sure. Maybe I can look together with Terry if creating these roles, and for the private part, I can give my insights.
Because quite a lot of people, I expect at least, will in the end be setting up their private stratum ones to have a full copy of the stack close to their system.
Yeah, I would say any HPC site that adopts EESSI will have to do this. So I think it's very important to have this properly documented, and with checks you can run and things to verify, and also the monitoring stuff is going to be very useful for a lot of people.
Definitely, yeah.
All right, very nice. Anything else to add, Ahmad, or?
No, not for me.
You joined a bit late. How was your experience over the hackathon overall? Organization wise and things like that?
Nice. That was nice. It was great that we could have these private groups and work on tasks, and even though this was not an official task initially, we made it into one, and it was that we could communicate and have this sync meeting in the middle. I think the setup was really nice. So
all right.
Yeah.
Excellent. Okay, let's see what else we have. Yuri's was another lone wolf.
Yes, so I was a bit surprised by that. So the motivation for my task is requirement from published scientific papers. They should offer access to data and software for 10 years to check and reproduce the results that they describe. So I think this will become more interesting the larger audience we reach, and we should have something like this. So I want to extend lifetime and availability of software delivered through EESSI. And the first obvious idea is just copy everything locally and set up some symlinks, right? The way we did it for decades. So I hit two issues here. First is that these symlinks should be present on the CVMFS itself. The issue is already open for that. They are not yet there. So this wasn't an option. I hope it will soon be. And the other issue I hit is that what others already mentioned is that the file system we were working on in Amazon wasn't all that fast, about as fast as a single mechanical hard drive, I guess. And that took over 26 hours to copy the whole EASY repository down to local space. And later deletion of that also took like 10 hours. So I quickly narrowed down my ambition to just pull out a specific software and pack that up in a container that can be then run independently of EASY. And what I came up with is a script that does that in a rough manner. So I had to do this on one part on this cluster in the cloud setup and the other part locally, because no containerization was available on this cluster in the cloud setup. So I had to pack stuff up in tarballs, copy them over and continue working on them locally. So the largest part or the most time-consuming part to copy was the compatibility layer. I had to look into it, how to trim it down, and I found large chunks of non-relevant data, let's say, in var, like var cache, var logs, var db. That probably kills the whole Gen2 portage setup, but I guess that's what we want to ensure that whatever we come up with remains unchanged in the future, right? So in there, we can dump almost 50% of the whole capacity of compatibility layer, trim it down to just slightly over 2 gigabytes. And then this is manageable, let's say, within 1 hour on Amazon. So some sizes that I came up with, so just copying compatibility layer plus EASY build FOSS 2020 that's available is 1.5 gigabytes. Adding GROMAX on top is then 1.8 gigabytes, and largest one I could find is R bioconductor that's a bit over 8 gigabytes. So I can pack this up in a singularity image and just briefly check that these things actually work. There are, of course, room for improvements. So the way I handled environment is not too nice. I mean, I just copied the output of environment on the Amazon, and then in the image template for the container, I picked up stuff out of there that looked relevant, that could be done better. So I'm thinking that I could probably also copy this init scripts from EASY and rerun those in the container. That would make more sense. Also, I would move those to the, not in the image template, but in the script that's gathering all of this stuff. So that's that script prepares a file that ends up in singularity environments as a part of a startup. So at that stage would also probably make sense to integrate some of these reframe tests to ensure that the result is sane. Not sure yet if we should run those at image creation or at image startup. I guess some of those would end up at the creation and at least some at the startup as well, just to ensure that the architecture that the images run on can actually run the binaries that are in the container maybe. And while I was explaining what I'm working on to our folks, our boss came up with an interesting question. So can we assign some of these digital object identifier to the resulting images so that they can be referenced in papers and so on? So this is something that I want to throw out to you guys and see what you guys think about that.
Yeah, I think that could be a good idea, but I guess the question is then, when do you create the container image? So right now we don't plan to change anything anymore in .06 unless Gentoo starts reporting security issues in there. Then we're going to do the necessary updates in the compat layer. I don't think we will touch the software layer unless we have to. So does that mean, yeah, redoing the whole image dance and having a new DOI? Yes, it probably does. But yeah, as long as that's not a big problem, then this could make sense. Yeah, you're essentially making a snapshot of EESSI at a certain point in time and saying this is where I was running my experiment. So yeah, that could make sense. For some of the things you hit here, so the slow I/O performance, we didn't do any tuning at all there. Certainly not in cluster in the cloud. I didn't even look at how the I/O setup is done. Where were you running this download? Was it just on the login node, or did you create an interactive job and used one of the worker nodes?
I had to run this on the worker nodes. I think you explained that CVMFS is not available.
It's not mounted on, yeah.
So
And there,
anyway,
I think
on this shared file system, this elastic thing.
Yeah, so you have the EBS, so that's let's say the hard drive of the worker nodes. There's the mount shared, so that's going to be probably quite slow.
Yeah, that one. So home was sitting on that, and I used that.
Yeah, that's probably going to be very slow. So you probably don't want to use that for. I'm not sure what the bottleneck was, but I don't think it would be download, especially since we have. Well, okay, the Stratum 1 we have in AWS is not in the region where the cluster is running. That would also help. So we start up an instance in the same region where we have our Stratum 1 running in AWS. So the download is very quick since they're in the same network, essentially. That would already help. And then I think you have to make sure you're using the fast local disk of the worker node and not the shared EFS file system. So as long as we're talking gigabytes, there's going to be plenty of space there. And you even have special instances that have an SSD as a local drive rather than just the standard EBS. So those are a bit more expensive to spin up. But if you're doing something very IO intensive like this, it probably makes a lot of sense to use one of these SSD instances. So that, yeah, I'm not sure how much of a difference that would be. You still have to pull in quite a bit of data, but over 24 hours, that's rather extreme, I would say. So that's probably doable to get that down. And then the pseudo and singularity. So singularity is there in the worker node, but you're not able to build images because you don't have pseudo rights, I guess. Yeah, I think that's also fixable even without giving you pseudo. So singularity has this fake root thing, or if you're running in Rocky 8 or RHEL 8 and you have namespaces enabled, user namespaces, then you don't need pseudo at all. So that's definitely fixable as well. Yeah.
Okay, something for me to look into then.
Yeah. And the sizes, so even for FOSS, 1.5 gigs, that's without any cleaning on the EasyBuild side, right? So you're not removing build dependencies, you're not removing EasyBuild log files, things like this.
So yeah, I removed the EasyBuild log files. That's the only thing
Okay.
I removed from EasyBuild.
Yeah, but you're not trying to weed out only runtime stuff and no throwing out build dependencies. That's not done at all.
No.
No. Then
so
I would
what
say
I do is I just do a module load FOSS and then check up all the paths that modules point to and copy that stuff.
Okay, then you do actually remove build dependencies because when you do the module load, the build dependencies are not loaded.
Yes, correct.
Yeah. Okay. So yeah, that I guess that explains why it's so, well, I wouldn't say small, but reasonable in terms of size.
Yeah, it's manageable from time perspective as well.
Mm-hmm. Yeah. Yeah. Cool.
Does it make? Sorry.
Good result. Yeah. York, go ahead.
does it make any sense to include the build dependencies as well, in case we need to reproduce what we have done? It's one of these questions, I know.
It depends on what the target is, right? If you want to just archive stuff for redoing scientific experiments, you're not going to need any build dependencies for that. You just want to be able to run the software. But yeah, you could make it optional to archive everything. So basically, rather than loading the modules, you could ask EasyBuild what needs to be available, and that would include all the build dependencies as well. So that would be a very easy change to make.
I know it is one of these questions like, how long is a piece of string?
It depends on the use case a lot, but yeah.
Exactly. I imagine that end user, they will just use these containers as a base from which they will populate their own, I don't know, scripts or workflows or whatever. So in that case, I think including build dependencies would make sense, yes.
Yeah, it also depends which one. Something like CMake, yeah, probably yes. But whatever stuff we need in EasyBuild to build our own GCC, so there's a lot of stuff behind that already. You probably don't care about that, because as soon as you have the GCC built with EasyBuild, you can throw away everything that was needed to build that. So there's definitely something you can maybe always clean up. But things like CMake or yeah, other build tools, which I don't want to name, you could include as well. So all the scripting you did here, Yuri, are in the hackathon repo?
In the repository, yeah.
Yeah. We should maybe figure out what we're going to do with that. I guess this belongs in the file system layer, and Bob, in some kind of subdirectory there, script export or whatever you want to call it. That would probably be a better place to put it.
Yeah, that makes sense.
Yeah, so my idea is to have another hackathon style iteration on this to polish up things I already identified and maybe throw it around a bit so you guys can give some input. And then after a couple of rounds, I guess it can land in the repository itself, in the CVMFS admin.
And then I guess the next question would be, if we have a bunch of images, where do we park them? Or is that something you already have an answer to?
Right now, I would say it's up to whoever runs the scripts to figure out how to handle this, because we can't really offer unlimited space for people to store these images. But at least the institution where this scientist is working at should have something available, I guess.
Does it make sense to ship a base container on CVMFS with the EasyBuild installation so that we can always point to some kind of base, which then on top gets built all of the other stuff?
We could, for example, give a base container with the compat layer, so they don't have to redo that.
Things, yes.
Yeah, because that's clearly a big chunk here of the 1.5 gigs, probably one or even a bit more than one. Is the compat layer. So if you already have that as a base container, it would speed up things a lot. And you basically opt in, I want GROMACS and R, and please give me a container for that. Yeah, that could help. Yeah, as long as the size is reasonable and 1 gig, I guess we could even park this in GitHub in the container registry there, and just allow you to easily pull that down as a starting point. Yeah. And the compat layer doesn't change very often. I mean, 06 hasn't changed basically since it was created. Or maybe once we had to do a security update there, so it's very, very infrequent. So it's even doable if we want to, every time we make a change in the compat layer, to also regenerate those container images that can serve as a base. That probably makes sense. All right, cool. Yeah, there's a Hugo who wasn't able to join the meeting this afternoon. He did some work on Azure support and cluster in the cloud. All I know is that it's a work in progress. I couldn't find any pull requests for that. Maybe it's sitting in his branches or in his local working repository. But yeah, if you're interested in that, I would say ask Hugo in Slack what the status is of that. I know it's an ongoing work for several weeks already, not just during the hackathon. And then to wrap up, unless somebody else has any comments or questions or things to mention, this was the first hackathon, this wild idea, and see how it works. And I think we can say it was a very good outcome. We predicted chaos. I dare say we didn't really get any chaos. Maybe that will happen next time, we'll see. But we have another one already planned mid-January. Basically another opportunity to burn some more of these AWS credits that we're going to lose. So whatever we don't spend is going to be gone. And we do hope to get a new year of credits, basically. So we're going to work with Christian on that in January. But everything we have currently, we can basically burn and try to make good use of it. So doing another hackathon makes sense. And maybe we can be a bit more aggressive, or with testing or GPU or God knows what. Anything else to mention? Any questions, or shall we wrap up? No. All right. Let's wrap up here. Thanks a lot, everyone who joined. I hope it was fun, and I hope we can see you again during the next hackathon.
Good work, everybody.
Thank
Thanks,
you.
everyone.
Good work.
Bye-bye.
Thank you, everyone.
Bye.
Bye-bye.
Bye-bye.
Bye.
Bye.
Bye-bye.
Thanks. Have a nice weekend, everybody.
You
Bye-bye.
too.
Bye, Ork.
You too.
Bye.
You too.